Hello and welcome to Aircraft Tutorials by Captain. In this video, I'll be showing you the 767 cockpit as well as how to start the engines on the 767. This is a screenshot on Microsoft Flight Simulator 2004 using Level D Simulations product 767. Hope you enjoy. We'll start on the left. This instrument is called the Mach airspeed indicator. And all it does is it shows the speed at which the aircraft is going through the air in Mach and in airspeed. Airspeed is always in knots for the aircraft. This is a dual RMI. This shows two different navigational aids in reference to the aircraft. So this one is showing that there's a nav aid behind us at 31.7 nautical miles. Over here is a radar. This shows our track, which in this case we're going 256 degrees, heading 256. Along this line, this is a magenta line that's created when the pilot puts the route into the flight management computer. It also shows the aircraft position in reference to that waypoint, in this case MCI, as well as the wind that's outside. In this case it's a 52 knot headwind. Moving up is the artificial horizon, the electronic artificial horizon. Right here is a speed tape, and this is the exact reflection of this, only in digital format, of course. Now the only difference here is that it has a red tape here on the outside, and what this shows is that this is the overspeed range. You never want to go in here because you'll go too fast and you'll tear the airplane apart. Over here, these words show what mode we have the autopilot in. In this case, you have the auto throttles on, and we're telling it to hold speed, hold a certain speed. Altitude hold, lateral navigation, LNAV. LNAV is just telling the airplane to follow this magenta line, and CMD, command, which is just telling us that the autopilot is actually activated. Okay? Moving on to the right, we have the altimeter. It's indicating that we're at 36,000 feet above sea level. Down here is the VSI, vertical speed indicator. It shows how fast the aircraft is going up or down in thousands of feet. So the 1 would represent 1,000 feet, and the 0.5 would be half 1,000 feet, which is 500 feet. And this here is just a clock that the pilots use for various purposes. Now over here, something called the auto brakes. Now, the auto brakes are used on landing when the aircraft touches down on the ground. When the pilot selects each individual setting, that tells the aircraft how fast to slow down. Down here are the radar control buttons. Radar control buttons. Now, on the real airplane, they're not actually located here. They're actually located somewhere else on the pedestal, but I'll show you that later. Over here is a backup indication for the engine instruments, just in case the main primary display goes bad. Over here is our annunciator panel. An annunciator panel shows all the cautions and warnings of the airplane. Moving up, over here on the left, we have one of the two VOR nav radios. Over here has the autopilot. So over here is the flight director button, or switch I should say, switch. Now flight director is just a visual indication of what the autopilot is telling the aircraft to do. Auto throttles, right now it's on, speed is selected, like over here, like it says. And 0.836 is being held. 0.836 is being held. Now, even here it says heading 265, although it's not showing that heading on the radar. That was the last one that was told on takeoff. Right now, as you see, LNAV is selected, like here, and that's what is following the lateral navigation, following the magenta line. Over here is the vertical speed. Obviously this is blank because we're not going up or down. and it's holding altitude at 36,000 feet. Holding altitude. And right here, the command button shows the autopilot's on. Moving right along, we have the upper and lower ICAS panels. Now, ICAS is spelled E-I-C-A-S, and it stands for Engine Instrument Crew Alert System. And displayed on here, we have N1 and EGT. N1 is the measurement of the rotation of the big fan that you see on the front of the engine, and EGT is the exhaust gas temperature. That's the temperature of the hot air coming out the back of the engine. In this green, we show the cruise setting for the engines. Now this is a maximum that this can go. So the computer will not allow the engine to go past 102. And right now it's showing 90.8. Going down here, we have different various engine instruments: oil pressure, oil temperature, oil quantity, and engine vibration. N2 actually starts N1, and I'll show you that when we actually get to the starting part of this video. But this is what you look at. This is called the starter turbine, or the high pressure compressor. This is called the low pressure compressor. And this is what you look at when you're starting the engines. And FF is fuel flow. Now, fuel flow and EGT on American aircraft are in Fahrenheit and pounds per hour, respectively. Now, of course, in foreign airlines, they may change it to their metric system. But in this case, this product and the options that are chosen for this one are in the American system. Over here is the flap indication. Right now they're at 0, which means the flaps aren't down because, well, we're flying. This is the gear handle. Right now it's in the off position, and the reason that's in the off position is because if in case that when we land and we put this down, the gears aren't going to come out. We have to be able to put the gear down in an emergency situation, and we can't do it while it's in the up position. So, and over here are the different, we can push in the different various phases of flight. So this one is takeoff, go around. This one's climb, and right now you can't see it, but over here would be climb, or cruise, excuse me. And right here, cruise. So right now this is selected because we're in cruise flight. Moving on to the overhead, we'll start on the top left-hand corner. This is the IRS panel, the inertial reference system panel, and what this does is this shows many things, but in this case it's showing the current position of the aircraft in flight. This is the yaw dampener button. Now, the yaw dampener is actually extremely important. What it does is that it keeps the rudder from falling off the airplane. Let me explain. On faster airplanes, the rudder actually tends to do something like this. And without the yaw dampener, this can eventually break off and cause the aircraft to crash. What this does is it helps prevent it from doing this. So it just keeps it straight. This is the electronic engine control. It does many functions, but one of the functions I can tell you, and that you saw on the previous page, is that it helps the engine not exceed its limits. So you saw cruise 102%. That helps it prevent from going beyond that. Over here is the hydraulics control panel. Here we have engine-driven pumps, electric-driven pumps, and demand pumps. Now, demand pump is what's unique on the 767. 767 and the 757 are very similar, but one difference that you can tell is that the 757 does not have demand pumps. Over here are the anti-air panels for the overhead. HF radios, high frequency. This is what's used on transoceanic flights, the Atlantic Ocean and the Pacific Ocean. Battery. Moving on to the electrical panel, this is the battery. Standby power, which is an auto. Standby power, when the engine generators fail, this automatically kicks in and gives basic navigation and engine indication so pilots can safely land. APU generator, bus ties, and utility buses. Now, all that buses are just big units that control different systems on the airplane. That's all they are. And these are the engine generators. All these buttons do is turn them on. Very simple. Over here is the APU control panel. This knob turns it on, and this indicates that it's running or not. Over here is the cockpit voice recorder, and this is the microphone that picks up the voices. This is rain protection, this is rain repellent, and the wipers. Engine anti-ice. Now, anti-ice and de-icing are two different things. De-icing takes off the ice or snow that's already on the airplane, and anti-ice prevents snow or ice from getting on there. So, two different systems. This is the fuel indication. Now, this, like I told you, is an American plane or an American airline that I have on the product. So this is showing it in pounds. So 16,800 pounds in this tank, 5,100 in the center, and 16,009 in the right tank. Like I said, airlines on the other side of the world may have it in the metric system in kilograms. Moving on, these are the fuel pumps. 767 has 2 on the left, 2 on the right, forward and aft, and 2 in the center. And these are the cross-feed valves. Cross-feed valves allow fuel to go from here to here and vice versa. Over here is the fuel jettison system. Fuel jettison system is when the aircraft is too heavy and it needs to make an emergency landing, the pilots can dump fuel overboard. Over here is the engine control. This turns on the engines. Right now it's in auto. And this over here switches the igniters. Now when the engine's getting started, there's actually igniters inside the engine that heat up the fuel and the air and that make it burn, and that actually starts the engine. That's what gets it going. This here is a ram air turbine, more commonly known as a RAT, and all that is a giant propeller off, I believe it's the right side of the aircraft, that sticks out, and it provides basic electrical and hydraulic power to the airplane when the engine generators fail. Right here is the system that drops the oxygen masks if it doesn't automatically go. Cargo heats and window heats. Now the reason there needs to be cargo heat is because if you don't do it, you get on the ground, you'll have blocks of ice, and obviously that's not a good thing. Window heats, of course, because we don't want to freeze to death. Another HF radio, just like on the left side. Same function, same everything, just on the right side. Cabin call buttons. Smoking seatbelt signs. Pressurization control panel. Pressurization gauges. Equipment cooling. If equipment doesn't get cooled, it can burn up, and, well, the airplane burns up. Now, this is the bleed air panel. Bleed air is just air that separates and goes all around the airplane. That's all it is. In this case, we have air coming from the engines. All this white little indicator means is that the valve is open. That's all it means. Valves open on the left side, valves open on the right side, valve is open on the left engine, valves open on the right engine, and valve is closed for the APU. This little gauge right here shows the amount of pressure in the bleed air duct, in the tubes inside the system itself. These two knobs control the PACs. Now what those PACs mean are PACKS, pneumatic air conditioning kits. And that's just the air conditioning units inside the airplane. And then this is just a thermostat. Right now, they're set at 70, 74, and 74. And remember, this is in degrees Fahrenheit, because this is a United States airplane. Now, onto the center pedestal. On this product, the 767 Level D simulators, behind here there's a button that you can push in order to get this panel to show. Starting on the left, like again, this here is called the parking brake. To activate it, you push up on the rotor pedals and you pull up on the handle. These buttons over here are part of the FMC, which I'll show you in the next scene. This is called the stabilizer trim, and what that is it helps trim out the elevators on the back, which are on the back of the aircraft, and helps keep the aircraft in level attitude flight. Over here is called the spoilers, or the speed brake handle. And the spoilers, if you ever sit on the wings, are the things that pop up out of the wing. And what that does is that it helps slow down the aircraft and spoil or destroy the lift on the aircraft upon landing, so the weight of the plane can be on the wheels, and so the aircraft can stop flying, so we can safely slow down to a stop. These are throttles. These are thrust thrusters. And on landing, these are what's used to help slow down the airplane. Right here is the flap handle. Here's the radar control and the decision altitude selector. Right here is the stabilizer trim gauge, position gauge. Here are the fuel control knobs. Right now they're in the run position because, of course, this screenshot, like I said before, is in flight, so they obviously need to be on. Stabilizer cutout, just in case the automatic stabilizer function ceases to work. Over here are two VHF, very high frequency radios. These are communication radios used over land. Over here are the fire handles for the engines and for the APU. In the event of a fire, you're going to see this turn red, and what you do is you pull up and you twist. Here's the transponder. This code 4545 is what the simulator gave this airplane and this particular flight. So when the air traffic controller in the simulator sees it, it can identify as easily, just like in the real world. In the real world, the transponder gives aircraft information, like the type and the altitude, and the air traffic controller can see it on the radar. Over here is the mic selector. You can choose whichever radio you want to talk to or listen on. Over here is a rudder trim. This helps, just like the stabilizer trim, helps keep the aircraft straight. Here we have the FMC, a flight management computer, which is part of the FMS, the flight management system. Now, down here on this product, just like here, here's the pedestal button, and here's the FMC button, and here's the overhead button. These are the three buttons that you can push on this product to get the various panels that you've been seeing pop up. Like now, this is the FMC, and the FMC has popped up. Now this is an example of the legs page. Now the way this is read is that this is the next waypoint on the list, and we are 130 nautical miles away, and the best fuel efficient speed is 0.776 Mach, and of course the flight level that we've chosen is 36,000 feet, FL 360. Flight level 360 is also known as 36,000 feet. And this is 7 pages long, so this is 1 out of 7 pages. And so on. This is the course to get to here. Now to get to winds, it's 19 nautical miles between air and winds, and you have to travel at heading of 276 and at this fuel efficiency. Now, when you get down here, the computer calculates that the best fuel efficiency is not 0.776, but 0.775. And of course, it's the pilot's option to go by it or not. Usually they do go by it to save fuel. Over here are the various pages that you can choose. And of course, here's the letters and numbers that you can type in over here in what's known as the scratch pad. Now here's a general overview of the 767 in flight. Now if you notice on the first scene, you didn't notice these. These are standby instruments. Now these are separate from the main. In case the main goes out, the pilot can fly by these standby instruments. It has an attitude indicator, an altimeter, and an airspeed indicator. And there's the FMC. And over here, the company has an option to put a weather radar if they choose. Some do, some don't. This product does not allow does not offer a weather radar. See, there's the gear handle in the off position, and here's the 3 computers that the autopilot has. You can push either one, and on landing, actually all 3 are chosen for redundancy, safety, and backup. Now over here, on the overhead scene, I wasn't able to show this, but over here are the exterior lights. Here's the landing lights, taxi lights, runway turn-off lights, beacon, nav, and strobe lights, and logo lights. And over here are various interior lights like map and dome lights. And over here, this is what's called a tiller. Now the tiller is what the pilot uses to steer the aircraft on the ground. Over here is 2 knobs, or 2 switches rather, that control the elevator trim that the pilot can use. It's electrically actuated. Here's the pilot's oxygen mask and the speaker to hear radio calls. Behind the first officer, you see here called the maintenance panel. Now, the pilot doesn't have to do anything with the maintenance panel except for one thing. Right here, those green lights. Those green lights indicate the condition of what's known as a squib. Now, the squib is what actually extinguishes the fire. So, all the pilot has to do with this is push this first button up here, and you're going to see all the green lights come on. However, when the pilot pushes this button, all the lights, with the exception of this middle one right here on the bottom, comes out. Why? I'm not completely sure, but that's how the 767 simulator, or the systems are. And that's it for this side. Now here's a picture of a real 767 that I was in once, back in 2007. And I'm just going to go over everything, not in detail like I did before, but I'm just going to point out everything that this particular company has. Here's the IRS panels, as you can see, in nav. Align, ATT, and off. When the pilot's about to fly, they push these knobs into nav. Yaw damper, EECs, hydraulic control panel. See the demand pumps? 767 has them, 75 does not. APU control, electric generator, panel, battery, standby power, HF radio. Now see, this is what the HF radio looks like when it's on. The pilot didn't use this because this flight was not transoceanic, but it is dialed in. Engine control panels, fuel jettison, fuel panel, fuel quantity, wipers, anti-ice, pressurization control panel and gauges, cabin call buttons, the other HF radio, the air conditioning panel, and the bleed air panel. Moving on to the aft center pedestal. I understand this might be a little bit blurry, but you can still really nicely see everything. Here's the rudder trim, a VHF comm radio, then the fire handles. Left engine, right engine, and the APU. And here's the mic selector switch on this particular 767's pedestal. Moving on to the upper center pedestal, we see the FMC, the weather radar. Now this is the weather radar that I was telling you about that the airlines can have the option for. Of course, this airline chose it. Here's the speed brake handle, radar control panel, stabilator cutoff, fuel control knobs, throttles, reverse thrusters, and flap handle. This is a picture of the first officer's side, as well as the center instrument panel. We see the upper ICAS panel and the lower ICAS panel. This is the flap indicator, gear handle, electronic checklist that this airline chose to have, dual RMI, Mach airspeed indicator, electronic attitude indicator, radar, VSI, clock, altimeter, radar altimeter, and over here are the limit buttons that I was telling you about in the previous scene. This is the autopilot. Starting over here, you see one of two. This is the right, this is the left, one of two VHF nav radios. Here's the flight director for the first officer. Here's the 3 command buttons on this aircraft. Some airlines have 6, which is what these 3 blank spaces are. here's the little tab to disengage the autopilot. What you do is you pull it out like this, and you disengage it. To put it back, you just push it back up. Altitude, VSI control, heading control, and speed control. Here's a separate control for the auto throttle. So you just push this on, and even without turning on this autopilot, it'll automatically control the speed. Or if you shut this off and you just turn the autopilot on, it'll do everything else but this. And here's the flight director switch option for the captain. Here's the demonstration part of the video that will show you the actual startup of the engines on this airplane. First, we go to the overhead, turn on the battery, and we switch the APU knob into the start position, and you'll see these indications: fault, and then run, run. Now, all the fault means is that the APU is not actually on or online. Now, what happens when you turn the APU switch into the start position is two things. First, the battery voltage drops, and then the APU inlet door opens. Once the APU inlet door is completely open, then it activates the starter turbine in the APU and helps it start spool up. Now all we have to do is wait. Alright, the APU generator has kicked in and all this instrumentation pops up. Now we go back to the overhead, open the APU bleed valve, open up two pack valves, and I turned on the packs even though you don't really need to, just to show what it looks like. The hydraulics are turned on just to show what it looks like because you really don't need them on, except the engine driven pumps. You turn on the fuel pumps. Switch the igniters in order to preserve each individual igniter. Now when you actually turn on the engines, you have to turn off the packs to get most air into the pneumatic starter, and then you switch to ground. Now when you switch to ground, the bleed air valve opens, lets air into the starter turbine, spins the N2 high pressure compressor, and this is the indication we see, 18%, 19%. Now in this aircraft, with these kind of engines, the maximum N2 is 23%. Then you open the engine valve and spar valve. The engine valve is a fuel valve that's actually from the pylon to the engine, and then the spar valve is from the fuselage to the wing. And then it starts up its cycle with the starter still going, and then you're going to see it click. Now when you see it click, then power is there you go. See that click? That click means that the power is transferred from the APU generator to the engine's generators. And when that happens, you'll see the starter switch in the auto position. That's something you must verify, otherwise the starter will still rotate and burn up. Now, as an added bonus, I've decided to show you what it looks like when an engine generator has failed. Oh, startup procedures for the engine are exactly the same. You switch the engine igniters as necessary, and then you move the engine start switch to ground. And when you move the engine start switch to ground, remember, the valve opens, lets the air through to the starter turbine, spins the N2 compressor, and when N2 gets to 23%, open up the fuel valves. Now remember, 23% N2 is for the CF6 engine. The Rolls-Royce engine may be different. See, now the engine's generator has taken the power from the APU. So now the APU is no longer supplying power to the right generator bus. Now that air is being supplied from the engines, we can turn the packs back on and shut the APU bleed air valve off because we no longer need the APU. Now, when the engine generator fails, you're going to see an indication in amber saying that the right generator has failed, or the left one, whichever one it is, and that click that you just saw. See? Right generator failed. That's the top ICAS warning, or caution, excuse me. Warnings are in red, cautions are in amber. And that click, that means it clicks off. See? Off. Right generator is inoperative. Well, thanks for watching. Hope you enjoyed. Bye.